You just dropped your phone. That sickening crack echoes in slow motion as it hits the pavement. The screen is a spiderweb of shattered glass, and it won't turn on. For a split second, your heart stops. You think about the 2,000 photos from your last vacation, the hundreds of contacts you've collected over a decade, the years of text messages with your family, your friends, your partner. It's all just gone. Or is it? You walk into a store a little defeated and buy a new phone. You take it out of the box, connect to the Wi-Fi, and type in one single password. And then the magic happens. Over the next few minutes, you watch as your life flows back into this new device. Your photos reappear in your gallery. Your contacts populate your address book. Your apps start downloading already logged in. That half-written email to your boss is sitting right there in your drafts. This isn't magic. This is the cloud. And you've been using it every single day in 100 different ways, probably without ever truly understanding what it is. And that's a problem. Because in 2026, not understanding the cloud is like not understanding the internet in the year 2000. It's the invisible architecture of our entire world. And it's quietly powering a revolution that is changing everything about how we work, live, and even think. From the Netflix show you binged last night, to the banking app you used this morning, to the GPS that got you to work, it all runs on the cloud. The most valuable companies on Earth, Amazon, Microsoft, Google, aren't just tech companies anymore. They are, at their core, massive, world-spanning cloud companies. They are in $1 trillion arms race for the future, and that future is built on the cloud. So what is it? If you ask most people, they'd say it's online storage, like a floating hard drive in the sky. And that's not just wrong, it's dangerously wrong. It's like describing the entire global financial system as a place to keep your cash. It completely misses the power, the scale, and the mind-boggling importance of what's actually happening. This video is going to fix that. Over the next few minutes, I'm going to give you a simple, powerful explanation of what the cloud actually is. No confusing jargon, no boring technical diagrams. By the end of this, you will understand this fundamental force better than 99% of the population. You'll be able to explain it to your friends, your boss, or your family, and you'll finally see the hidden machinery that makes the modern world turn. Understanding this isn't just for tech geeks. It's for anyone who wants to understand the economy, the future of their career, and the technology that will define the rest of their lives. First, let's get one thing straight. The cloud is not a cloud. It's not some ethereal, wispy thing floating in the atmosphere. The cloud is a physical thing. It's a global network of millions of powerful computers, stacked in racks inside colossal, hyper-secure, air-conditioned buildings called data centers. These buildings are some of the most advanced structures ever built by humankind, and they are strategically placed all over the planet. When you save a photo to the cloud, you aren't sending it into the sky. You're sending a copy of it to one or more of these computers in one of these anonymous-looking buildings, which could be in Virginia, Oregon, or even Ireland. But the cloud isn't just about storing stuff. That's a tiny piece of the puzzle. The real revolution of cloud computing is about one thing: renting, not owning. To understand this, we're going to use a simple analogy. Forget computers for a second. Let's talk about making a pizza. Imagine you want to start a pizza business. In the old world, the pre-cloud world, you had to do everything yourself. This is called on-premise, as in on your own premises. You have to buy or lease a building. You have to install the plumbing and the electricity. You have to buy the ovens, the refrigerators, the mixers, the countertops. Then you have to buy all the ingredients: the flour, the water, the yeast, the tomatoes, the cheese. Then you have to actually make the dough, cook the sauce, prepare the toppings, bake the pizza, and serve it. You are responsible for everything, from the foundation of the building to the final slice of pepperoni. This is how companies used to run their technology for decades. They bought their own servers, the powerful computers that run websites and applications. They had to house them in their own special air-conditioned rooms. They had to manage the power, the networking, the security, and hire a whole team of people just to keep the lights on. It was incredibly expensive, slow, and inefficient. Then the cloud came along and offered a better way. The first level is called Infrastructure as a Service, or IaaS. Think of this as renting a fully equipped professional kitchen. You don't own the building. You don't own the ovens or the refrigerators. You don't have to worry about the plumbing or the electricity bill. You just pay a fee to use the kitchen and all its equipment. You still have to bring your own ingredients, your flour, your cheese, your sauce, and you still have to have your own recipe and your own chefs to cook the pizza. But you've outsourced the massive headache and expensive building and maintaining the kitchen itself. This is what companies like Amazon Web Services, or AWS, first offered. They built the massive data centers, the kitchens, and let other companies rent their computers, their storage, their networking on a pay-as-you-go basis. A startup like Airbnb didn't need to spend millions building its own server farm. It could just rent the raw infrastructure from Amazon and build its empire on top of it. This is infrastructure as a service. You manage the pizza recipe and the ingredients, but someone else manages the kitchen. But what if you don't want to worry about shopping for ingredients either? That brings us to the next level: platform as a service, or PaaS. In our pizza analogy, this is like signing up for a meal kit delivery service but for your restaurant. The professional kitchen is still provided, but now the service also delivers all the prepackaged, pre-measured ingredients right to your door. They give you the perfect pizza dough, the perfectly seasoned tomato sauce, the pre-shredded mozzarella. All you and your chefs have to do is assemble the pizza according to a simple recipe and pop it in the oven. You don't have to worry about building the kitchen, and you don't have to worry about sourcing the ingredients. You just focus on the final act of creation. In the tech world, PaaS providers give developers the servers and also all the tools, the databases, the operating systems, the software development kits that they need to build their applications. They don't have to worry about managing the underlying infrastructure or the platform tools. They just focus on writing their unique code, their special recipe to create their app. Now, for most of us, this is the level of the cloud we interact with every single day. It's the final and most common level: software as a service, or SaaS. This is simple. You don't want to build a kitchen. You don't want to buy ingredients. You don't even want to cook. You just want to eat a pizza. So you go to a restaurant, or more likely, you pull out your phone and you order a pizza to be delivered to your door. Hot, delicious, and ready to eat. You don't care about the oven they used, or where they got their tomatoes. You are just consuming the final product. This is software as a service. Think about it: Gmail. You don't own the email servers. You don't manage the email software platform. You just open your browser or your app and you use it. Just works. Netflix is SaaS. You don't manage a giant video library or the complex streaming technology. You just press play. Salesforce, Dropbox, Microsoft 365, these are all examples of SaaS, where you are paying a subscription fee to use a finished piece of software without worrying about a single thing that happens behind the scenes. So, on-premise is making the entire pizza from scratch, including building the restaurant. Infrastructure as a service is renting the kitchen. Platform as a service is renting the kitchen and getting the ingredients delivered. And software as a service is just ordering the damn pizza. This is the fundamental secret of the cloud. It isn't one single thing. It's a spectrum of choices. It's a model that allows anyone, from a single person with an idea to a Fortune 500 company, to decide exactly how much of the work they want to do themselves, and how much they want to pay a hyper-efficient, global-scale expert to do for them. It's a shift from owning to renting, from massive upfront costs to a flexible, pay-as-you-go utility, just like your electricity. But this raises a giant question. If the cloud is really just a network of these massive physical data centers, these digital kitchens, then where are they? What do they look like? And how are they all connected to deliver a movie to your phone in a fraction of a second? The answer is far more incredible and far more physical than you could ever imagine. They are hidden in plain sight. They exist in quiet, unassuming towns, on the edges of deserts, and even near the Arctic Circle. They are the data centers, and they are the physical heart of the cloud. Forget the image of a fluffy, white, ethereal thing in the sky. The cloud has a physical address. In fact, it has thousands of them. Imagine you're driving through the high desert of Central Oregon. The landscape is sparse, beautiful, and empty. Then, on the horizon, you see it. A building, or rather, a collection of buildings. They are colossal, windowless structures, stretching for a quarter mile or more. They don't look like offices. They don't look like factories. They look alien. The only sound is the wind and a deep, low, constant hum, like a giant beast sleeping just beneath the earth. You've just found one of the cloud's digital kitchens. Getting inside one of these places is harder than breaking into Fort Knox. We're talking about multiple layers of security: man-traps, biometric scanners, armed guards. Because what's inside is, in many ways, more valuable than gold. It's the currency of the 21st century: data. Your data. My data. The data of billions of people and millions of businesses. If you were to pass through that security, the first thing that would hit you wouldn't be a sight, but a sound and a feeling. The hum you heard outside is now a deafening roar. The combined sound of tens of thousands of computer fans all spinning at once. And the air is cold. Intensely, artificially cold. You've walked into a machine-made hurricane. You'd find yourself standing in a cavernous hall. a cathedral of computation. Stretching out before you are endless aisles of tall black metal racks. Each rack is filled top to bottom with sleek blade-like computers called servers, thousands upon thousands of them, stacked like books in a futuristic library. The only light comes from the rhythmic, hypnotic blinking of millions of tiny green and blue LEDs. A city of digital fireflies winking in the dark. This is it. This is the cloud. When you upload a photo to Instagram, it doesn't float up into the sky. It's converted into bits of data that travel through a network and find a home on a specific hard drive, inside a specific server, in a specific rack, in one of these anonymous buildings. When you stream a movie on Netflix, a server just like one of these wakes up, finds the movie file, and sends a copy of it screaming across the globe directly to your screen. The sheer scale is almost impossible to comprehend. A single one of these server racks can store petabytes of data. 1 petabyte is 1,000,000 gigabytes. That's enough to store about 13 years of continuous high-definition video. Now look down that aisle. There are hundreds of racks. And this is just one aisle in one data hall. And this data center has multiple data halls. And this company, be it Amazon, Google, or Microsoft, has dozens of these data centers scattered across the planet. We are talking about a quantity of information that is truly astronomical. All of your emails, every photo you've ever saved to the cloud, every document, every song in your playlist, every single frame of every cat video you've ever watched. It all lives a physical life on a spinning platter or a solid-state drive inside one of these machines in one of these buildings. This immense scale is precisely why the cloud is so powerful. No single person, no single company could ever afford to build and maintain this kind of infrastructure. But by renting a tiny slice of it, you get access to effectively unlimited storage and unlimited computing power for pennies. You're leveraging the economy of scale of the biggest companies on Earth. But this raises a critical question. Why are these digital fortresses in such strange places? Why the Oregon desert or rural Iowa or northern Sweden? The answer comes down to 3 things that these machines crave more than anything else: power, cooling, and speed. First, power. A single data center can consume as much electricity as a small city. They need to be located near massive power grids, and ideally near sources of cheap, reliable, and increasingly renewable energy. That's why you see them popping up near hydroelectric dams and massive wind farms. Second, cooling. All those thousands of servers working 24/7 generate an incredible amount of heat. If they overheat, they fail. So a huge portion of that electricity bill goes to just one thing: air conditioning. Keeping the servers from melting themselves down is a constant, expensive battle. This is why companies are getting creative. Google has data centers that use recycled water for cooling. Microsoft has even experimented with sinking an entire data center to the bottom of the ocean. And Facebook built one in Luleå, Sweden, just 70 miles south of the Arctic Circle, so they can just open a window and pipe in the frigid Arctic air to cool their servers for free. And third, speed. Or more accurately, the lack of slowness, a concept called latency. The speed of light is the ultimate speed limit of the universe, and it's a real problem for a global cloud. If all the data centers were in California, someone in London trying to access their files would experience a noticeable delay, as the request had to travel across the country and under the Atlantic Ocean and back again. To minimize this lag, cloud providers build data centers all over the world, creating a distributed network. They place them strategically close to major population centers, creating what are called regions and availability zones, so that your data can be stored closer to where you are, making access feel instantaneous. But how do these separate, continent-spanning digital cities talk to each other? How does a request from your phone in Ohio get to a server in Oregon in the blink of an eye? This isn't happening through satellites. That's a common misconception. Satellites are way too slow for this kind of work. No, the global nervous system of the cloud, the thing that connects all of these data centers into a single functioning organism, lies on the ocean floor. We have wrapped our planet in a web of fiber optic cables. We're talking about hundreds of thousands of miles of hair-thin glass fibers, bundled into garden hose-sized cables, laid by specialized ships across the deepest, darkest trenches of the sea. These cables connect continents, carrying virtually all of our international internet traffic. When you send an email to someone in Europe, the data is encoded into pulses of light, shot through these undersea glass threads at nearly the speed of light, pops up on the other side, and is routed to its destination. This is the incredible physical reality of the cloud. It is not an abstraction. It is a planet-spanning machine of staggering scale and complexity. It's a network of windowless fortresses filled with light and noise, powered by entire cities' worth of electricity, cooled by Arctic winds and ocean currents, and all connected by a web of glass laid across the bottom of the sea. But this incredible picture raises an even more profound set of questions. If your data is just a file on a hard drive in one of these buildings, what happens if that hard drive fails? What happens if an entire server rack goes offline? What happens if a clumsy construction worker cuts one of those undersea cables with a backhoe? What happens if an entire data center, an entire digital city, is wiped out by a natural disaster? Does all your data, all your photos, all your memories just vanish forever? The answer is no. And the reason why is thanks to a piece of software-based magic, a clever illusion that makes 1,000 computers act as one, and one computer act as 1,000. It's the true secret sauce that makes the cloud work, a concept that completely changed the world of computing forever. This virtualization, it's the engine under the hood of the entire cloud. To understand it, we have to travel back in time just for a moment to the dark ages of the early 2000s. Imagine you're starting a small tech company back then. You need 3 things to get off the ground: a server to run your public website, another server to handle your company's internal email, and a third powerful server to manage your customer database. In that era, your only option was to go out and buy 3 separate physical machines. 3 big, noisy metal boxes. You'd spend tens of thousands of dollars on the hardware. Then you'd have to find a place to put them, a dedicated air-conditioned room, because these things generated a ton of heat. Your website server might be really busy during the day but do almost nothing at night. Your email server would be the opposite, mostly quiet during the day but busy processing and backing up emails overnight. And your database server? It needed to be powerful, but maybe it only used 10% of its full power on an average day. You were paying for 100% of the hardware, 100% of the electricity, and 100% of the space for all 3 machines 24 hours a day, even though you were only using a tiny fraction of their total potential. It was incredibly inefficient. It was like buying a 50-passenger bus just to drive yourself to work every day. You had all this wasted capacity, all this potential just sitting there burning electricity and gathering dust. This was the fundamental problem that was holding technology back. Then, a truly brilliant idea began to take hold: virtualization. The pioneers of virtualization asked a simple question: what if, instead of buying 3 separate medium-powered computers, we bought one single, incredibly powerful computer? A beast of a machine. And then, what if we used a special, clever piece of software to digitally slice that one physical machine into 3 separate, independent virtual machines? Think of it like this. Imagine a giant industrial pizza oven. The old way was to buy 3 small, separate ovens for your kitchen. One for your pepperoni pizza, one for your veggie, and one for your cheese. Each takes up space, uses its own power, and sits cold most of the day. Virtualization is like buying one massive, professional-grade pizza oven, and then using magic, heat-proof dividers to split the inside into 3 smaller, completely separate cooking chambers. The software that does this is called a hypervisor. It's the magic set of dividers. It's a thin layer of code that sits directly on the physical hardware of that super powerful server. The hypervisor's job is to carve up the real hardware, the processor, the memory, the storage, and present a fake or virtual set of that hardware to each of the digital machines it creates. So, from the perspective of your software, you still have 3 separate computers. Virtual machine number 1 gets its own virtual processor, its own virtual memory, and its own virtual hard drive. It can run the software for your website, completely isolated and unaware that it's not a real physical box. It thinks it's living in its own little apartment. Virtual machine number 2 gets its own apartment to run the email software, and virtual machine number 3 gets its own penthouse suite for the database. They all live on the same physical street, the same powerful server, but they are completely independent. The website server can crash, and the email server won't even notice. They can't see each other's files or interfere with each other's operations. They are living a lie, a beautiful and incredibly efficient lie, managed by the hypervisor. And this is the absolute fundamental breakthrough that made cloud computing possible. Companies like Amazon, Google, and Microsoft looked at this technology and realized they could apply it on a planetary scale. They didn't just buy one powerful server. They built colossal warehouses, data centers the size of multiple football fields, and filled them with hundreds of thousands of the most powerful servers ever created. Then, they layered this virtualization software, this hypervisor, over all of it. So now, when you go to Amazon Web Services or Microsoft Azure and you say, "I need a server," you aren't renting a physical metal box. You're not getting a guy in a warehouse to go plug something in for you. You are, in a matter of seconds, being handed the keys to one of these virtual machines. The hypervisor instantly carves out a slice of a giant server's resources, a little bit of processing power, a chunk of memory, some storage space, and presents it to you as a clean, fresh digital computer that you can access from your laptop anywhere in the world. This solved the old problems in a spectacular fashion. Remember our inefficient, expensive setup? First, the efficiency problem. With virtualization, the cloud provider can pack hundreds, sometimes thousands, of these virtual machines onto a single physical server. Your tiny blog's virtual server might be running right next to a massive bank's data processing virtual server, which is next to a startup's test environment. The cloud provider is like the ultimate Tetris player, fitting all these different workloads together perfectly to ensure that the physical server is being used to its maximum potential every second of the day. No more wasted power. This incredible efficiency is what drives the cost down, allowing you to rent a virtual server for just a few dollars a month instead of buying one for thousands. Second, the speed problem. In the old days, if your company suddenly needed a new server, it was a whole process. You had to order the hardware, wait for it to be delivered, rack it, stack it, and install all the software. Could take weeks. With virtualization, getting a new server is as simple as clicking a button. The hypervisor just carves out another slice of the existing hardware. What took weeks now takes about 30 seconds. This agility is a superpower for developers and businesses. It means you can try out a new idea instantly without any risk or massive upfront cost. Finally, and most importantly, is the problem of scale. What happens if your website, running on its little virtual server, suddenly goes viral? Maybe you're featured on the news, and 1 million people try to visit your site at once. In the old world, your single physical server would have been overwhelmed and crashed instantly. But in the virtualized cloud, you have a magic trick up your sleeve: elasticity. Because your server is just a collection of software settings, you can change its size on the fly. You can log into your cloud account and drag a slider to give your virtual machine more processing power, more memory, more everything. The hypervisor just allocates more of the underlying physical server's resources to you, instantly. Or even better, you can set it up to happen automatically. You can create a rule that says, if my website traffic goes up, automatically create 10 identical copies of my virtual server to share the load. And when the traffic dies down, those extra copies automatically disappear, and you stop paying for them. This is elasticity, the ability to grow or shrink your computing resources on demand, in real time. It's like your pizza oven's magic dividers being able to automatically resize the cooking chambers based on how big of a pizza you need to cook right now. This power, this flexibility, was simply impossible before virtualization. And the idea didn't stop there. Engineers kept asking, how can we slice things up even more efficiently? This led to the next evolution: containers. If a virtual machine is like renting a whole virtual apartment building to run your application, a container is like renting a single, perfectly furnished room. It's an even lighter, faster, more portable way to package and run software. Technologies like Docker and Kubernetes, which you hear about all the time, are built on this idea. They are the next generation of virtualization, allowing for even greater density and speed. It all comes back to that one core concept: taking a big, powerful thing and using clever software to slice it into countless smaller, isolated, and manageable pieces. This single idea dismantled the old world of computing, where power was locked up in expensive, inefficient physical boxes. It turned computing from a product you had to buy into a utility you could rent, like electricity or water. It is the foundational pillar upon which every single cloud service, every app on your phone, and the entire modern digital economy is built. But splitting up computers was just the first step. The real revolution began when companies started figuring out what to sell on top of these virtual slices, turning that raw, virtualized computing power into ready-made services. And that led to 3 acronyms that define the entire cloud industry today. Those 3 acronyms are IaaS, PaaS, and SaaS. Infrastructure as a service, platform as a service, and software as a service. Now I know what you're thinking. Great. More corporate jargon. I'm out. But stick with me, because understanding these 3 ideas is like getting the keys to the entire digital kingdom. And the simplest way to understand them is with pizza. Yes, pizza. Forget servers and data centers for a minute. Let's say your goal is simple. You want to host a pizza night for your friends. You have 4 ways to do this. The first way is the traditional, old-school, completely on your own method. We'll call this on-premises. This is where you decide to make everything, and I mean everything, from scratch. You're not just making pizza. You're building the entire supply chain. You have to buy the flour, the yeast, the tomatoes, the cheese, the pepperoni. You need to have your own kitchen, a working oven, a pizza stone, a cutter. You need electricity to power the oven, gas for the stovetop, water to make the dough. You need plates, silverware, and a table for your friends to sit at. You are responsible for every single component, from the raw ingredients to the final served slice. You have total control, but you also have total responsibility. If the oven breaks, you have to fix it. If you run out of cheese, you have to go buy more. If the power goes out, there's no pizza. This is exactly how companies used to run their websites and applications before the cloud. They would buy their own physical servers, those big humming metal boxes. That's the oven. They'd have to manage their own building with specialized cooling and power. That's the kitchen, the electricity, the plumbing. They'd install the operating system like Windows or Linux. That's the recipe book. They would manage the network cables, the storage drives, and all the underlying software just to get to a point where they could start building their actual product. It was incredibly expensive, incredibly slow, and required a massive amount of work that had nothing to do with the final application they were trying to build. It was like wanting to be a world-class chef but being forced to first become an electrician, a plumber, and a construction worker. This is where the cloud and our first acronym come in, IaaS, or Infrastructure as a Service. With IaaS, you decide that managing your own kitchen is a huge pain. You don't want to worry about the oven breaking or the power going out. So you rent a professional-grade, fully equipped kitchen. The owner of the kitchen takes care of the building, the power, the water, and makes sure the oven is always on and at the right temperature. They give you the fundamental infrastructure. But that's all they give you. You still have to go to the store, buy your own flour, your own sauce, your own cheese. You have to bring those ingredients to the rented kitchen, assemble the pizza yourself, cook it yourself, and serve it yourself. You're renting the tools and the space, but you're still the chef. This is the first layer of cloud computing. Companies like Amazon Web Services, Microsoft Azure, and Google Cloud will rent you the basic building blocks. They give you access to virtual servers, storage, and networking. You don't have to buy a single physical machine. You don't have to worry about the data center, the cooling, the power, or a server catching fire. They handle all of that. But you are still responsible for everything on top of it. You have to install your own operating system, manage all your own software, and build your application from the ground up on their infrastructure. It's a huge step up from the old way. It gives you flexibility and lets you pay only for what you use, but it still requires a lot of technical expertise. You've outsourced the kitchen, but you're still doing most of the cooking. But what if you wanted to do even less? This brings us to the next level, PaaS, or Platform as a Service. With PaaS, you realize that not only is managing a kitchen a pain, but so is making dough from scratch and simmering tomato sauce for hours. You just want to focus on the creative part, the toppings, and the final bake. So you go to a special kind of pizza place. They provide the kitchen, the oven, and they provide you with a ready-made pizza base. A perfect crust, already topped with sauce and cheese. They've built the platform for your pizza. All you have to do is add your unique toppings, your pepperoni, your mushrooms, your pineapple, and then put it in the oven to bake. You control the final product's flavor and how it's cooked, but you don't have to worry about the foundational, time-consuming parts. This is PaaS. The cloud provider gives you the infrastructure, the servers, the storage, the networking, **, they manage the platform on top of it. This includes the operating system, the databases, and the development tools. It's a complete environment where developers can just show up with their code, their unique toppings, and deploy their application. They don't have to worry about security patches for the operating system or configuring a database. The cloud provider handles all of that boring underlying work. This lets developers focus purely on what makes their application special. It's like the cloud company is saying, don't worry about making the dough. We've perfected the dough. You just focus on being a pizza artist. This is a massive accelerator for innovation. But for most of us, day to day, there's one final layer that we interact with constantly, often without even realizing it. And that is SaaS, or Software as a Service. With SaaS, you've had a long day. You don't want to manage a kitchen, you don't want to buy ingredients, and you certainly don't want to assemble a pizza. You just want to eat pizza, right now. So you pull out your phone, open an app, and you order a pizza delivered directly to your door. It arrives hot in a box ready to eat. You have no idea where the kitchen is. You don't know what brand of oven they used. You don't know their dough recipe, and you don't care. You are not buying ingredients or renting a kitchen. You are subscribing to a finished service that solves your problem, which in this case is being hungry. This is SaaS. The vast majority of cloud applications you use every day fall into this category. Think about it. When you open Gmail, you're just using the software. You're not managing Google's servers, you're not patching their operating systems, you're not writing any code. You just log in and it works. When you stream a movie on Netflix, you are the consumer of a service. You don't manage the massive infrastructure that stores and delivers petabytes of video data around the globe. You just press play. Microsoft 365, Salesforce, Dropbox, Slack, these are all SaaS products. The entire company, the software, the platform, and the infrastructure are all managed by the provider. You just pay a subscription fee and use the finished product over the internet. So let's recap the pizza journey. On premises, you do everything. You build the kitchen, buy the ingredients, make the pizza. Total control, total headache. IaaS, infrastructure as a service. You rent the kitchen and the oven, but you bring your own ingredients and do all the cooking. PaaS, platform as a service. The kitchen provides the pizza base. You just add your toppings and bake it. You manage your app, they manage the platform. SaaS, software as a service. You order a pizza. It just shows up ready to eat. You just use the software. These three models represent a spectrum from maximum control and maximum responsibility with IaaS to minimum control and minimum responsibility with SaaS. And here's the crucial part for 2026 and beyond. These models are not mutually exclusive. A single company might use all three. A tech startup might use IaaS to build a highly customized backend, use a PaaS database to manage their data, and then use a SaaS product like Salesforce to manage their customers. The cloud isn't one thing. It's a flexible set of services that lets you choose exactly how much you want to manage yourself and how much you want to pay someone else to handle for you. It transformed IT from buying products like servers to subscribing to services. And this shift created an entirely new battlefield. A titanic clash between a handful of giant corporations all vying to become the landlord of the entire digital world. The question was no longer just could you rent computing power, but who would you rent it from? The answer for a surprisingly long time was a bookseller. In the early 2000s, Amazon wasn't the everything store it is today. It was an online bookstore that had gotten very, very good at one thing: building massive, efficient, and reliable infrastructure to handle the insane traffic spikes of a holiday shopping season. They had built a system so powerful, so robust, that for most of the year a huge portion of it was just sitting there idle. And then, someone inside Amazon had a revolutionary thought. What if we rented out our spare capacity? What if we took this incredible internal tool we built for ourselves and turned it into a product? It was like a master carpenter who built the world's greatest workshop deciding to rent out his tools by the hour. In 2006, they launched two services that would quietly change the world. The first was called the Simple Storage Service, or S3. Think of it as a magic, infinite hard drive in the sky. You could store any amount of data, from a single photo to an entire company's archives, and only pay for what you used. It was revolutionary. The second was the Elastic Compute Cloud, or EC2. This was even more audacious. It was, quite literally, a computer you could rent by the second. Need a powerful machine for 10 minutes to run a complex calculation? Just click a button. Done with it? Click again and you stop paying. It was computing power turned into a utility, as simple and accessible as flipping a light switch. This new division was called Amazon Web Services, or AWS. And for years, the rest of the tech world either didn't notice or simply didn't care. They saw Amazon as a retailer, and this little side project seemed like a distraction. They couldn't have been more wrong. While the giants of the old world were busy selling software in boxes and servers in racks, AWS was building a secret empire. Startups who could never have afforded their own data centers flocked to them. Companies like Netflix, Airbnb, and Dropbox were born on AWS, able to scale from a garage project to a global phenomenon without ever buying a single physical server. Amazon wasn't just a first mover. They had the entire playing field to themselves for the better part of a decade. They were building the roads, the bridges, and the power plants of the new digital continent, while everyone else was still arguing over the blueprints. But eventually, the sleeping giants began to stir. The most formidable of these was Microsoft. For decades, Microsoft had been the undisputed king of computing. Their castle was built on two mighty pillars: Windows on the desktop and their server software in the office. They owned the enterprise market. And from their perch in Redmond, Washington, they looked at this new cloud thing with deep skepticism. Their CEO at the time, Steve Ballmer, famously scoffed at the idea. Why would their massive corporate clients, who spent billions on Microsoft software and servers, ever want to rent a faceless computer from a bookseller? To Microsoft, the cloud wasn't a revolution, it was a cheap commodity, a race to the bottom. This was a catastrophic miscalculation. By the time they realized their mistake, AWS had a 7-year head start and was generating billions in revenue. Microsoft was facing the classic innovator's dilemma. Their existing, wildly profitable business of selling software licenses was being threatened by a new model that looked, on the surface, less profitable and more complex. It was a moment of existential crisis. But then in 2014, a new CEO took the helm. His name was Satya Nadella, an engineer who had spent his career at Microsoft, and he saw the future with terrifying clarity. He knew that if Microsoft didn't pivot, and pivot hard, it would become a relic. He declared a new mantra: cloud first, mobile first. He took the entire, gargantuan battleship of Microsoft and began to turn it towards a single destination: the cloud. He launched Microsoft Azure, their direct competitor to AWS. But he did it with a brilliant strategic twist. He didn't just try to copy Amazon. He leveraged Microsoft's greatest strength: its deep, decades-long relationships with every major corporation on the planet. He told them, "You already use Windows. You already use Office. You already trust us with your data. Now let us help you move all of that to our cloud. We'll make it seamless." It was a powerful message. For a chief information officer at a Fortune 500 company, the choice was between a familiar, trusted partner in Microsoft or the retailer who just delivered their office supplies. Azure began to grow at an explosive rate, not by trying to out-innovate AWS on every feature, but by becoming the safe, logical, and integrated choice for the corporate world. The war was on. And then there was the third titan, the genius in the room: Google. If anyone should have dominated the cloud, it was Google. They had been living in the future for years. The very technologies that underpin the modern cloud, the ability to manage millions of servers as a single cohesive unit, to process unbelievable amounts of data in the blink of an eye, these weren't things Google had to learn. They were things Google had invented for their own use, just to make Google Search and Gmail and YouTube possible. They had more fiber optic cable, more PhDs in distributed computing, and more raw technical prowess than arguably anyone on Earth. When they finally decided to enter the market with the Google Cloud Platform, or GCP, the expectation was that they would blow everyone away. Their technology was, in many ways, more advanced. They were the pioneers of game-changing tools like Kubernetes, which became the industry standard for managing modern applications. They offered incredible expertise in data analytics, machine learning, and artificial intelligence, fields where they were the undisputed world leaders. But they had a problem. Google was a company of engineers, not salespeople. They were used to building incredible technology and letting it speak for itself. They weren't used to the messy business of enterprise sales, of support contracts, and of holding a customer's hand through a complex digital transformation. They had the best engine, but they struggled to sell the car. While AWS was the pragmatic first choice and Azure was the trusted corporate choice, Google became the sophisticated, high-tech choice. They attracted companies that wanted the absolute cutting edge, the best AI tools, the most advanced infrastructure. But they struggled to gain the same broad market share as their rivals. So the battlefield was drawn. It wasn't just a two-way race anymore. It was a three-way war between giants, each with a fundamentally different strategy. Amazon, the pioneer, the retailer who built an empire on speed and convenience. Microsoft, the incumbent, the enterprise king who leveraged its legacy to stage a stunning comeback. And Google, the innovator, the technology purist betting that the best tech would ultimately win. This wasn't just a corporate squabble over market share. The stakes were astronomical. The company that controlled the cloud would control the foundational layer of the 21st century economy. Every new startup, every bank, every hospital, every government agency, every car, every smart device, they would all need to live somewhere. These three companies weren't just selling server space. They were in a race to become the landlord for the entire digital world, collecting rent on nearly every single byte of data that flowed across the internet. And your life was already running on their real estate. That Netflix movie you streamed? Running on AWS. The Office 365 document you worked on? Powered by Azure. That search you just performed? Handled by Google Cloud. You were a citizen of this new world whether you knew it or not. The clash of these titans was shaping the very fabric of modern existence. And the war was only just beginning. But this war wasn't being fought with soldiers and tanks on some dusty battlefield. It was a war of ideas, of infrastructure, of pure computational power. And the weapons being deployed weren't made of steel, but of code. They had strange, acronym-laced names, but they were fundamentally changing how everything, from a blockbuster movie to a doctor's appointment, was created and delivered. To understand this new world of 2026, you have to understand the 3 core strategies these titans were using to win your business, your data, and your loyalty. They are known as infrastructure as a service, platform as a service, and software as a service. Now I know what you're thinking. Oh great, here come the boring technical acronyms. But stick with me, because understanding these 3 concepts is like being handed the keys to the entire digital kingdom. And the simplest way to grasp it is to think about Legos. Imagine you want to build an incredibly cool, custom Lego spaceship. Back in the old days before the cloud, building a digital service was like having to manufacture your own plastic, design your own brick molds, and create every single Lego piece from scratch before you could even start building. It was slow, expensive, and utterly inefficient. Nobody does that anymore. Instead, the cloud offers you a few options. The first and most fundamental is infrastructure as a service, or IaaS. In our Lego analogy, IaaS is like being given a massive, almost infinite box of basic Lego bricks. You get all the red 2x4s, the blue 1x2s, the flat green base plates, the wheels, the clear canopy pieces, everything you could possibly need. You have total freedom. You can build that spaceship, or you could build a castle, a race car, or a whole city. The choice is yours. You have the raw materials. This is exactly what Amazon Web Services did with offerings like EC2, Elastic Compute Cloud. They weren't selling a finished product. They were selling the building blocks. They sold access to virtual servers, raw storage, and networking. A company like Netflix in its early streaming days didn't want to buy a pre-built video player. They needed to build a global planet-spanning delivery network, something that had never existed before. They needed the raw bricks. They needed IaaS. They could rent 1,000 servers for an evening to handle the Friday night movie rush, and then scale back down to 100 servers on a quiet Tuesday morning, only paying for what they used. This was revolutionary. The power of a global data center, available with a credit card. But here's the trade-off. With all those bricks, you are the master builder. You are responsible for everything. You have to design the spaceship, assemble it piece by piece, make sure the wings don't fall off, and ensure the engine is stable. In technical terms, you manage the operating systems, the security patches, the databases. You have ultimate control, but also ultimate responsibility. But what if you don't want to be a master architect? What if you know you want to build a spaceship and you just want to get it done fast? That brings us to the second layer, platform as a service, or PaaS. In our Lego world, PaaS is like buying a high-end Lego Star Wars kit. The Millennium Falcon, for example. You open the box and not only are the bricks there, but they're sorted into numbered bags. You get specialized, pre-molded pieces for the cockpit and the laser cannons. Most importantly, you get a detailed instruction manual. You don't have to worry about the fundamental engineering of a spaceship. The Lego designers have already done that for you. Your job is to follow the instructions, assemble the pieces, and maybe add a few of your own custom modifications. You're still building, but you're building on top of a platform that someone else created. This is what services like Google App Engine or Heroku provide. They give developers a platform where the messy, underlying infrastructure, the operating system, the server maintenance, the database connections, is already managed for them. A developer can just upload their code, and the platform takes care of the rest. Imagine you and your friend have a brilliant idea for a new photo-sharing app. You don't want to spend 6 months figuring out how to configure servers and manage network security. You just want to write the code that makes your app's filters look amazing. You would use a PaaS. It dramatically speeds up development. You give up some of the granular control you had with IaaS. You can't rebuild the spaceship's engine from scratch, but in exchange you get to build and launch your application at lightning speed. You focus on your unique creation, not the plumbing underneath. This leads us to the third, and most common level of the cloud. The one you interact with dozens of times a day without even realizing it. Software as a service, or SaaS. If IaaS is the box of raw bricks and PaaS is the Lego kit with instructions, then SaaS is the fully assembled, perfectly finished Lego Millennium Falcon, handed to you in a display case. You don't build a thing. You don't assemble anything. You just get to use it. You pick it up, you fly it around the room, you enjoy it. The product is finished. This is Gmail. This is Dropbox. This is Slack, Salesforce, Microsoft 365, and yes, Netflix. When you open your laptop and log into your email, you're not managing a mail server. You're not writing code for a user interface. You are simply using a sophisticated piece of software that is delivered to you, ready to go, over the internet. You pay a subscription or watch some ads and the service just works. It's the final tangible product that is built upon the other layers. And here's the secret that ties it all together. These layers are a stack. A huge SaaS company like Salesforce, which provides a ready-to-use platform for businesses, might run its own application on a PaaS environment to speed up its development. And that PaaS environment, in turn, is running on a vast collection of servers, storage, and networks, the IaaS layer rented from a provider like AWS. It's a pyramid of services with the raw infrastructure at the bottom and the user-friendly applications you use every day sitting at the very top. So the war between Amazon, Microsoft, and Google isn't just about one thing. It's a multi-front war fought across all three of these layers. They compete fiercely to provide the best raw building blocks, the best IaaS. They fight to offer the most efficient and powerful construction kits, the best PaaS. And they all offer their own finished models, SaaS applications, to capture end users directly. The choice for a company is no longer if they will use the cloud, but how. Which layer of this new reality will they plug into? Do they need the total control of raw infrastructure, the speed and convenience of a platform, or the simplicity of a finished piece of software? This decision is one of the most critical strategic choices any modern business can make. It defines what they focus on, how fast they can move, and ultimately how they compete. But choosing your weapon, IaaS, PaaS, or SaaS, is only half the battle. The other half is choosing the terrain on which you'll fight. Because not all clouds are created equal. As companies move their most sensitive data and their most critical operations into these rented data centers, a deep-seated anxiety began to grow. Who really controls this data? How secure is it, floating out there in someone else's computer? This gave rise to a new front in the cloud war. A battle over location, security, and control. A battle between the open frontier of the public cloud, the fortified castle of the private cloud, and a strange, powerful new creation that promised the best of both worlds, the hybrid cloud. This hybrid cloud wasn't just a compromise. It was a strategic masterpiece. Imagine you own a small high-end workshop right behind your house. It's your private cloud. It's secure, you have complete control over every tool, and it's perfectly customized for your most important, sensitive projects. This is where you keep your secret formulas, your most valuable blueprints. But what happens when you get a massive order that requires a giant industrial press and a team of 50 workers for just 1 week? You're not going to build a whole new factory for a temporary job. Instead, you rent space and equipment at a massive, shared industrial park down the road. That's the public cloud. The hybrid cloud is the system that lets you do both seamlessly. It's the dedicated, high-speed road connecting your private workshop to the public industrial park. You can keep your core, sensitive operations in-house, under your direct control, while leveraging the immense on-demand power of the public cloud whenever you need it. You get the security and control of the castle with the infinite pay-as-you-go resources of the open frontier. This model solved a huge problem for established companies, especially in finance and healthcare. A bank, for example, is legally required to keep its customers' financial data under incredibly strict security, often within its own data centers. That's their private cloud. But that same bank wants to build a slick new mobile app with cutting-edge AI features to predict fraud. Building that AI from scratch would cost billions and take years. But the public cloud providers like Amazon, Google, and Microsoft have already built those powerful AI tools. With a hybrid strategy, the bank can keep all the sensitive customer account data safe and sound in its private castle, while sending anonymized transaction data with no personal information attached, out to the public cloud for analysis by these powerful AI engines. The results are then sent back to the private cloud. It's the perfect marriage. The security of a fortress, combined with the world-class intelligence of a global tech giant. Or think about an online retailer. For 10 months of the year, their website traffic is predictable. They can handle it easily on their own private servers. But then comes November, Black Friday, Cyber Monday. Suddenly, their traffic multiplies by 100 or even 1,000 times. In the old days, they'd have to buy enough servers to handle that absolute peak. And for the rest of the year, 95% of that expensive equipment would sit there idle collecting dust. It was incredibly wasteful. The hybrid cloud introduced a concept called cloud bursting. The retailer runs its normal day-to-day website on its private cloud. But as the Black Friday traffic starts to surge, the system automatically bursts into the public cloud, seamlessly redirecting the overflow traffic to rented servers from a provider like AWS. The website never slows down. No sales are lost and customers are happy. Then, when the sale is over and traffic returns to normal, the system scales back down, and the company stops paying for those extra public cloud servers. They only pay for the extreme power precisely when they need it. It's like a dam that can instantly open spillways into a massive reservoir during a flood, preventing a disaster. For years, this hybrid model seemed like the ultimate answer. You had your secure home base and you had your powerful, flexible rental space. But then a new question emerged. Why rent from just one industrial park? What if the park owned by Company A has the best metal presses, but the park owned by Company G has a revolutionary new 3D printing facility? And what if Company M offers the cheapest warehouse storage? You wouldn't want to be locked into using just one provider if you could get better tools or better prices by using all three. This line of thinking gave birth to the next evolution, the multi-cloud. If the hybrid cloud is a bridge between one private castle and one public frontier, the multi-cloud is a global network of highways connecting your castle to every major frontier simultaneously. A multi-cloud strategy means a company isn't just using its own private cloud and one public cloud provider. It's actively using services from 2, 3, or even more public cloud providers at the same time. This sounds complicated, and it is. So why would anyone do it? The reasons are as brilliant as they are strategic. First, and most importantly, avoiding vendor lock-in. Companies that went all in on a single public cloud provider in the early days started to get nervous. They had moved all their data, retrained all their staff, and rebuilt all their applications to work perfectly on, say, Amazon Web Services. They were completely dependent on Amazon. What if Amazon decided to dramatically raise its prices or discontinue a service they relied on? They would be trapped. Switching to a competitor would be a monumental, expensive, and time-consuming task. A multi-cloud strategy is the ultimate defense against this. By building applications that can run on both AWS and Google Cloud, for instance, a company keeps its options open, creates competition. They can shift workloads to whichever provider offers the best price or the best performance. It gives the customer the power, preventing any single tech giant from holding them hostage. It's like owning both a Visa and a MasterCard. If one place doesn't accept one, you always have a backup, and you can choose the one that gives you the best rewards. The second reason is using the best-of-breed services. The big cloud providers are all innovating at a breakneck pace, but they don't all excel at the same things. It's widely recognized that Google Cloud has some of the most advanced and user-friendly artificial intelligence and data analytics tools on the planet. Microsoft Azure has deep, seamless integrations with the Windows and Office software that nearly every corporation in the world already uses. And Amazon Web Services has the widest, most mature range of fundamental services, from storage to computing. With a multi-cloud approach, a company doesn't have to choose. They can be a connoisseur. They might use Google's BigQuery to analyze their sales data, run their core Windows applications on Azure to make their IT department happy, and use AWS S3 storage because it's known for being incredibly reliable and cost-effective. They get to pick the absolute best tool for each individual job from a global menu of options, rather than being stuck with the mixed bag of tools from a single provider's toolbox. And the third reason is the ultimate form of resilience. We like to think of the cloud as this infallible, magical thing, but it's still made of physical servers in physical buildings on physical land. And things can go wrong. Fiber optic cables can be cut. Power grids can fail. A software bug can cascade through a provider's entire network, causing a massive hours-long outage. In 2021, an outage at a single AWS region took down a huge chunk of the internet, affecting everything from streaming services and robot vacuums to airline booking systems. If your entire business runs on that one provider, an outage like that means your business is completely offline. But in a multi-cloud world, you have the ultimate insurance policy. You can design your systems to automatically failover. If the East Coast region of AWS goes down, your traffic can be instantly rerouted to run on Google Cloud's infrastructure in the central United States. For your customers, there's no interruption, no downtime. Your application just keeps working. It's the digital equivalent of having your New York headquarters backed up by a fully operational, ready-to-go office in Chicago. So the cloud landscape had evolved from a simple choice between public and private to a sophisticated game of chess. Companies were now acting like master strategists, building hybrid systems for security and multi-cloud architectures for flexibility, cost savings, and resilience. They were no longer just renting a server. They were architecting a global, interconnected, and fault-tolerant digital nervous system for their entire organization. But this raises a critical question. We've spent all this time talking about the where, the physical data centers, the public clouds, the private clouds, the hybrid connections. We've essentially been talking about the hardware, the digital real estate. But what are companies actually building on top of all this infrastructure? What are the actual services they're buying? It's not just a raw server. It's a whole new way of delivering software, platforms, and tools. We've established the foundation, the global infrastructure. Now, we need to look at what's being built on top of it. So what are these layers? What's actually being sold? Think of it not as a single product but as a spectrum of services, a ladder of abstraction. To make this crystal clear, we're not going to talk about computers for a minute. Instead, let's talk about something we all understand: getting around. Let's talk about cars. Imagine you need a car. The traditional old-school way, what we'd call the on-premise equivalent in the tech world, is to buy one. You go to the dealership, you pay a huge amount of money up front, and you drive it home. But your responsibility has just begun. You have to pay for insurance, registration, and gas. You have to handle all the maintenance, the oil changes, the tire rotations, the engine checkups. If it breaks down, that's your problem. You have to store it in your garage, keep it clean, and worry about its depreciation. You have total control, yes, but you also have total responsibility and a massive initial cost. For decades, this is how companies handled their computing. They bought physical servers, the expensive cars, and put them in a closet or a dedicated room. They were responsible for the power, the cooling, the networking, the maintenance, the security, and replacing them every few years. Total control, but also total cost and total headache. Then the cloud came along and offered a better way. The first and most fundamental layer of cloud services is called Infrastructure as a Service, or IaaS. In our car analogy, this is like a long-term car lease. You don't buy the car. You don't have that huge upfront capital expense. A company, say Ford or Toyota, provides you with the physical car. But that's where their responsibility ends. You are still responsible for the gas, the insurance, and keeping it clean. You get to decide where you drive it, what music you play, and who rides with you. You're in the driver's seat. IaaS is the exact same concept for computing. A cloud provider like Amazon Web Services, Microsoft Azure, or Google Cloud provides you with the fundamental building blocks of a data center: the virtual servers, the networking, and the storage. You're essentially renting their hardware. You don't have to worry about the physical building, the power bills, the cooling systems, or what to do when a hard drive fails. The cloud provider handles all of that. But you are still responsible for managing everything on top of that hardware. You have to install the operating system, Windows or Linux. You have to manage the security patches, install the databases, and configure the virtual network. You have maximum flexibility and control over your virtual environment, without the nightmare of managing physical machines. This is for companies that need deep control, maybe for legacy applications or highly specific configurations. They want to lease the car, but they want to be the one driving and maintaining it. But what if you don't want to worry about all that? What if you just want to focus on your journey, not on the engine? That brings us to the next layer up the ladder: Platform as a Service, or PaaS. In our car analogy, this is like a classic car rental from a company like Hertz or Enterprise. When you rent a car, you don't worry about the oil changes, the tire pressure, or the engine maintenance. The rental company takes care of all of that. They provide you with a fully functional, ready-to-go platform, a car that starts and drives. All you have to do is get in, maybe add some gas, and drive to your destination. You're focused on your application, the journey, not the underlying platform, the car's mechanics. PaaS is the developer's dream. The cloud provider manages not just the physical hardware, but also the operating systems, the development tools, database management, and business analytics. It gives developers a framework, a platform, where they can build, test, and deploy their applications without ever having to worry about the underlying infrastructure. They just write their code and upload it. The PaaS provider handles the rest, making sure the server is running, the operating system is patched, and that it can scale up if the application suddenly gets popular. It dramatically speeds up the development process. Developers get to focus on what they do best: building amazing applications, not being a part-time systems administrator. They don't care about the car's engine. They just want to build the world's best GPS app to run inside it. Now we get to the top of the ladder, the layer that nearly every single person listening to this uses every single day, whether they realize it or not. This is Software as a Service, or SaaS. Let's go back to our car analogy one last time. You need to get from your apartment to the airport. You could buy a car on-premise. You could lease one IaaS. You could rent one for the day pass. Or you could just pull out your phone, open an app like Uber or Lyft, and tap a button. A few minutes later, a car shows up. You get in the back. You don't drive. You don't navigate. You don't pay for gas, insurance, or maintenance. You don't even own the car. You are simply consuming a service transportation. You pay a small fee to be taken from point A to point B. That's it. All the complexity is completely hidden from you. That is software as a service. It's a ready-to-use application that you access over the internet, usually through a subscription. Think about it. Do you use Gmail or Outlook 365? That's SaaS. You don't manage the email servers, the software updates, or the spam filters. You just log in and use it. Do you watch Netflix? That's SaaS. You don't own the movie files or manage the massive video streaming servers. You just press play. Do you use Dropbox to store files, Salesforce to manage customers, or Slack to communicate with your team? It's all SaaS. You are the end user of a sophisticated piece of software that is entirely managed by someone else. You pay a monthly fee and it just works. This is by far the most common and fastest growing segment of the cloud. It's how software is delivered in 2026. The days of buying a CD-ROM in a box and installing a program on one computer are long gone. Today we subscribe to services in the cloud. So let's recap the three main layers. Infrastructure as a service (IaaS) is renting the raw hardware, like leasing the car and managing it yourself. It offers the most control. Platform as a service (PaaS) is renting a ready-made environment for building applications, like renting a car where all the maintenance is handled for you. It's for developers. And software as a service (SaaS) is consuming a finished product, like calling an Uber. You just use it. It's for everyone. Each layer of this stack involves handing over more responsibility to the cloud provider, which in turn gives you more time to focus on what actually matters for your business or your life. These three models, IaaS, PaaS, and SaaS, have defined the cloud industry for over a decade. They provide a clear, tiered way to understand the services being offered. But here's where the story takes a fascinating turn, pushing us toward the future. The lines between these neat little boxes are beginning to blur. And an even more abstract, more powerful model is emerging that is flipping everything on its head all over again. It promises even greater efficiency and less management. It's a concept that is fundamentally changing how applications will be built for the next decade. It's called serverless computing, and despite the name, it still involves servers. The secret is, you just never have to think about them again. So let's unravel this mystery. How can you have computing without servers? The best way to think about it is to compare it to your home's electricity. 100 years ago, if you wanted power, you had to own and maintain your own generator. You had to buy the fuel, perform the maintenance, and if it broke, it was your problem. That was like owning your own servers in your own data center. It was expensive, complicated, and a massive headache. Then the power grid came along. Suddenly, you didn't need a generator anymore. You just plugged your toaster into the wall. You didn't have to think about the power plant, the transmission lines, or the transformers. You just used the electricity you needed, and you were built for exactly what you used. If you went on vacation and turned everything off, your bill was close to zero. That's the revolution. Serverless computing is the power grid for code. Before serverless, even in the cloud, you were still basically renting a generator. With infrastructure as a service, you rented a virtual server. You didn't own the physical machine, but you were still responsible for managing the operating system, the security patches, and figuring out how big of a generator you needed. If you rented a big one and didn't use it much, you were wasting money. If you rented a small one and suddenly got a huge surge of traffic, your website would crash. Then came platform as a service, which was better. The cloud provider managed the operating system for you. But you still had to make a crucial decision. How many servers do I want running my code, and for how long? You were essentially paying for servers to be on, sitting there 24/7 waiting for someone to visit your app. Even if nobody showed up all night, you were still paying for those servers to be awake and ready. It was like paying for a dedicated power line to your house that was always on at full capacity, even when you were asleep. Serverless completely shatters this model. It introduces a concept called functions as a service, or FaaS. And this is the key. Instead of deploying an entire application onto a server, you break your application down into tiny individual functions. A function is just a small piece of code that does one, and only one specific thing. Think of it like this. The old way was like hiring a full-time employee to be your company's receptionist. That person sits at the front desk 8 hours a day. If the phone rings, they answer it. But if the phone doesn't ring for 3 hours, what are they doing? They're still sitting there. And you're still paying them for every single one of those hours. That employee is your server, always on, always costing you money. The serverless way is like having a magical, on-demand receptionist. This receptionist doesn't exist until the exact moment the phone rings. The instant a call comes in, they materialize out of thin air, answer the phone perfectly, do their job, and the second they hang up, they vanish. You only pay for the 5 seconds they were actually on the phone, not for the hours they were waiting. That's a serverless function. It's a piece of code that does nothing, costs nothing, and doesn't even exist until it's needed. It's triggered by an event. An event can be almost anything. A user uploading a photo to your app is an event. That event can trigger a function that automatically resizes the photo into a thumbnail. A customer clicking the buy button on your website is an event. That can trigger a function that processes their credit card. Someone sending a message in a chat app is an event. That triggers a function that pushes the message to the other user's phone. The code for that function is just sitting in the cloud. When the trigger happens, the cloud provider Amazon, Google, Microsoft instantly finds a tiny idle slice of compute power on one of their millions of servers, runs your code, delivers the result, and then shuts it all down. The whole process might take 100 milliseconds, and you are only billed for those 100 milliseconds. So, when we say it still involves servers, we mean that yes, your code is physically running on a server somewhere. But it's not your server. You don't manage it, you don't patch it, you don't scale it, you don't even know it exists. The server is completely abstracted away. It's the cloud provider's problem. Your only job is to write the function. This leads to 2 almost unbelievable benefits. First, the cost savings can be astronomical. Imagine you run a website that helps people file their taxes. Your traffic is insane in March and April, but for the rest of the year, it's almost zero. With the old model, you'd have to pay for a huge fleet of servers all year round just to handle that 2-month peak. With serverless, you pay a massive amount during tax season because you're getting a massive amount of use, and for the other 10 months, your bill could be literally pennies. You pay for value, not for idle time. Second, and this is the part that feels like a superpower, is the effortless, infinite scalability. Let's go back to our photo sharing app. What happens if your app is mentioned by a celebrity and 1 million people try to upload a photo in the same minute? In the old world, your servers would melt. Your site would crash. It would be a catastrophe. In the serverless world, nothing. Just works. If one person uploads a photo, the cloud provider spins up one instance of your function to process it. If 1 million people upload a photo at the exact same time, the cloud provider, without you doing anything, will spin up 1 million separate parallel instances of your function. It scales instantly and perfectly to meet the demand, whether that demand is 1 request or 10 million requests. Then, as soon as the rush is over, it all scales back down to 0. Automatically. This level of elastic scalability was the stuff of dreams for developers just a decade ago. Now it's built in. This changes everything. It allows a single developer working from their bedroom to build an application that can handle the same amount of traffic as a global enterprise, and to do it on a shoestring budget. Companies like Netflix use this extensively. When they get a new movie from a studio, they have to encode it into dozens of different formats and resolutions for every possible device, from an iPhone to a 4K television. They use serverless functions to do this. They can break the movie into thousands of tiny chunks and have thousands of functions process all those chunks in parallel. A job that might take a single powerful server days to complete can be finished in minutes, for a fraction of the cost. This isn't just a new technology. It's a fundamental shift in how we build software. It's the ultimate expression of the cloud computing promise. To pay only for what you use, to have limitless resources on demand, and to focus on writing code, not on managing infrastructure. We've moved from owning the generator to renting the generator, to now just plugging our code into the wall and getting billed for the exact amount of electricity it consumes down to the millisecond. But this incredible on-demand, infinitely scalable computational power is not the end of the story. It's the foundation. It's the stage being set for the next, even bigger revolution. Because once you have this global, invisible supercomputer that can run any code, anytime, at any scale, the next logical question is, what kind of code should we run on it? What are the truly world-changing applications we can build? The answer to that is what's defining the technology landscape of 2026 and beyond. Serverless computing is the engine, and the fuel that's about to be poured into it is data. Unfathomable amounts of data. When these two forces combine with the power of artificial intelligence and machine learning, well, that's where the future truly begins. It's a future where your doctor doesn't just treat your symptoms. They prevent the disease from ever happening. How? An AI running on a massive cloud platform analyzes your genetic data, your real-time health metrics from a smartwatch, and compares it against millions of anonymous patient outcomes from around the globe. It spots a pattern, a tiny statistical anomaly that no human doctor could ever see, and flags a potential issue years before it would have become a problem. This isn't science fiction. This is the promise of cloud-scale artificial intelligence. Think about the AI tools you might be using right now, from generating images to writing code. Where do you think they live? They aren't running on your laptop. They are colossal models with hundreds of billions, even trillions of parameters, living on tens of thousands of specialized processors humming away in a cloud data center. They require a scale of power and data that is simply unimaginable outside of the cloud. The cloud provides the stadium, the AI provides the players, and data is the game being played 24/7. This integration is leading us toward a concept that tech visionaries call ambient computing. The idea is that technology becomes so deeply woven into the fabric of our lives that it essentially disappears. It becomes like the air you breathe or the electricity in your walls. You don't think about the power grid when you flip on a light switch. You just expect light. Soon you won't think about the cloud when you get into your car. You'll just tell it where to go. The car will communicate with thousands of other cars and traffic signals in real time, all coordinated in the cloud, to find the absolute fastest, safest, and most efficient route. You won't think about the cloud when you speak to a tourist in a foreign language. Your earbuds will just translate their words for you instantly. The processing happening on a server halfway around the world in the blink of an eye. This is the ultimate evolution of the cloud. From a place you consciously store files to an invisible, intelligent layer that anticipates your needs and enhances your reality. But to make this seamless, real-time world a reality, the cloud itself has to evolve. It has to get closer. This brings us to one of the most important shifts happening right now, edge computing. Imagine that self-driving car again. It's cruising down the highway and a deer suddenly leaps onto the road. The car's sensors see it. Now, does it package up all that sensor data, send it hundreds of miles away to the nearest massive data center, wait for the AI there to analyze it and send a command back saying, "Brake"? Of course not. The round trip, even at the speed of light, would take too long. You need the decision to be made in milliseconds. Edge computing solves this. It's about bringing the processing power of the cloud closer to where the data is actually being created, to the edge of the network. So, instead of one giant centralized brain, you have smaller, powerful mini-brains located closer to the action. This could be a small server box on a cell tower, a processing unit inside the car itself, or a computer in a factory managing the robots on the assembly line. These edge devices can make critical, time-sensitive decisions instantly. They still talk to the main cloud to get big updates, share important findings, and contribute to the larger intelligence, but they handle the immediate tasks on their own. The cloud is no longer just a distant fortress. It's extending its nervous system out into the real world. And if edge computing is the cloud expanding outwards, then quantum computing is the cloud leveling up into a different dimension entirely. Forget everything you know about computers working with ones and zeros. That's classical computing. It's incredibly powerful, but it has limits. There are certain types of problems so complex with so many variables that even the biggest supercomputer on Earth would take billions of years to solve them. These are problems like designing brand new molecules for life-saving drugs, creating new materials for ultra-efficient batteries, or accurately modeling the global climate. A quantum computer doesn't think in ones or zeros, thinks in possibilities. Thanks to the bizarre principles of quantum mechanics, it can explore a vast number of potential solutions all at the same time. It's like a classical computer trying to find its way out of a massive maze by trying one path, hitting a dead end, going back, and trying another. A quantum computer could explore every single path in the maze simultaneously. The potential is staggering. Now, are you going to have a quantum computer on your desk anytime soon? No. These are incredibly complex, fragile machines that have to be kept in supercooled, highly controlled environments. So how will anyone ever get to use one? You guessed it, through the cloud. The major cloud providers, Amazon, Google, Microsoft, are in a race to build stable, powerful quantum computers. And they will offer access to them the same way they offer access to everything else, as a service you can rent. A researcher at a university or a small biotech startup will be able to log into a cloud portal and run calculations on a quantum computer, tackling problems that were considered unsolvable just a few years ago. So what does this all mean for you? It's easy to hear all this and think it's just for giant corporations and scientists. But the single most powerful aspect of the cloud is its democratizing force. For the first time in history, Anyone with a good idea and a credit card has access to the same level of computing power as a Fortune 500 company. The next revolutionary app, the next billion-dollar business, the next world-changing AI doesn't have to come from Silicon Valley. It can come from a college dorm in Kansas, a garage in Florida, or a small office in Detroit. You don't need to build a server farm. You just rent one. You don't need to hire a team to manage infrastructure. You just click a button. The cloud has lowered the barrier to entry for innovation to almost zero. It is the great equalizer. This creates opportunities we can't even imagine yet. New jobs will be created that we don't have names for today. Entire industries will be born. Artists will create in new mediums powered by cloud-based AI. Entrepreneurs will solve problems that were previously too expensive or complex to tackle. But with this immense power comes immense responsibility. As the cloud becomes the invisible foundation of our society, questions of data privacy, security, and ethics become paramount. Who owns the data that fuels this new world? How do we ensure the AIs being trained on it are fair and unbiased? How do we protect our digital lives when everything from our cars to our coffee makers is connected? These are not just technical questions, they are societal questions. And being an informed citizen in the 21st century means having a basic understanding of the infrastructure that powers it. We began this journey with a simple question. What is cloud computing? We started with the analogy of a digital storage locker, but we've seen it's so much more. It's the global supercomputer that powers our streaming services and our social networks. It's the engine for the artificial intelligence revolution. It's the invisible, ambient nervous system of our future world, extending its reach through the edge and preparing to leap into a new reality with quantum. The cloud is not a trend. It's the new utility. It's the electricity of the 21st century. It's the digital bedrock upon which everything else is being built. So, perhaps the question we should be asking in 2026 is not what is the cloud anymore. The real question is, what will we build with it? The servers are spinning. The data is flowing. The foundation has been laid. The future is not something that is just happening to us, it is being compiled right now in the cloud. And every one of us has a chance to help write the code.